Hi guys, so this is a video about how to plot your data. The analysis is going to be all up to you, but this is a video on how to plot your data. So let's get started. First things first, what you have to do is open up a new Excel workbook. Just go, open it up, and the book magically appears. After that, what you want to do is, for the total number of specimens that you have, you guys are going to have 3 plus 2, 5 plus 3, 8 total specimens. Open up 8 sheets. But for this demonstration, I'm only looking at 3 specimens, so I'm going to do 3 sheets. All right. Go to the folder that contains your data, the CSV file. So I'm looking at brass, aluminum, and 1020 steel. All right. So in that order, go back to your workbook, save it somewhere. Let's say all right, so this sheet, you go, you hit rename, you call it brass, aluminum, and your 1020 steel, like that, right? Or you can right click and rename, or you can double click slowly, single click, double click, like that, boom. All right, so now you go to brass. All right, then you go to the brass. Okay, I need too many windows open. Windows close. Okay, so now you go to the folder that contains your data. Go there. Where are your documents? Are you there? Yep. All right. So open up all your data. Brass. Boom. Aluminum. Boom. It's 1020 steel. Boom. All right. Now copy all your data. Hit Control A, Control C. 1020 steel and paste them in the appropriate sheet, right? Paste 1020 steel into 1020 steel. Boom. All right, that's my 1020 steel. Copy paste done. Then I go to aluminum. To copy everything, you can just click that button and copy it. You can also go to file, edit, copy, or you can do Control C. Do that. Then you just go to aluminum and hit Control V. Boom. There you go. All right, let's look at brass. Control A, Control C. Go to brass. Boom. There you go. All right, now let's enter the length between the grips to find out your backup measure of strain. So let's call that guy L. That was measured in millimeters. And for brass, let's say it was 100. You guys measured it in centimeters or in millimeters, right? So I'm going to say it's in millimeters because everything else is in millimeters. It makes life easy. Then do that for the other specimens of yours. Now I'm just getting the same one for all of them because, you know, I didn't do any measurements because I'm not meant to, but enter this L for the different specimens that you measured, all right? The distance between the grips, all right? Okay, next, go back and enter the area. Now the area is easy to do. I'll tell you why. Leave it in millimeters squared, right? Okay, now with your 2 dimensions of your W and T that you measured, you don't even need to do the math beforehand. You can let Excel do it. So just say equal to, for my brass, I have 12.5 wide, 12.5 millimeters wide, and I have 6.3 millimeters thick. Boom, I get my cross-sectional area in millimeters squared. Do the same thing across all your notebooks. So you can copy paste the heading, paste it there, paste it there. Then do the same thing that you did for brass. So for my aluminum, I have 12.8 times 6.3. Lovely. And then for my 1020 steel, I have 13.3 wide times 6.2 thick. Boom, there you go. So you leave that in millimeters squared. Now you convert your force into stress. right? So write it stress MPa, because that's the unit of stress. Now, the reason we left this in millimeter squared, it's going to become really, really evident. Just say this is equal to your load, which is your force, divided by this A. But make sure you fix that A, and you fix it by putting these dollar signs in front of the G and the 3. The dollar sign in front of the G will just fix this guy. If you have to go across, the dollar sign in front of the G will just fix the row number for whichever way you have to go. But just remember, if you hit dollar sign for both, you'll fix that particular cell. All right, enter. Then this is the best part about Excel. Just click that and go all the way down. Go all the way down. Go just drag it all the way down. Drag, 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 drag. And it'll stop kind of automatically when it reaches on the end on its own. Boom, there you go. So now you have all the stress measurements that you need. And what you can do is you can set this workbook up beforehand and then just enter it in one sheet, have all the sheets, space them out, rename them, and your workbook will, all you have to do is just enter the data. And it just makes things life super simple. All right, anyways, so what I mean by that is you can just copy this, go to aluminum and hit paste with formulas. It's going to calculate the formula on this sheet for you. Just hit that again, copy, select that particular column where you want to paste it. Make sure you hit formulas. Boom, easy peasy. It does it for this workbook for you. How easy is that? All right, here, go to strain. And this is going to be a backup strain, right? So backup strain. So remember, the backup stress is the delta L over the L for the distance between the grips, right? This guy's going to be mm per mm, right? That guy is going to equal delta. So to find the delta, it's going to equal this coordinate minus this one, but you're fixing the first one, right? So that's how you get the delta L, the displacement for how your thing moved, for how your top crosshead moved. You divide that by this guy here. Again, this guy, you fix it. Fix. Boom, like that. And again, you do that rolly down thing. Beautiful. All right, let's do copy paste again. Control C, go to aluminum, hit that guy. Go right click, go say formulas. Look at that, like magic. The strain got measured over there for you. Go back here, select that guy, and hit paste again, hit formula, and boom, you have thing. So now you have all the data you need to plot your curves. So to plot the curves, go back to whichever thing you want to plot it in, select a cell, go to insert, and the kind of data that you want is scatter data, right? It's going to be a 2D line. So actually, no, it's not going to be a 2D line. It's going to be scatter. This one, sorry, this one, scatter plot, right? So select this. This kind of makes it better, and you see your data as a straight line. Kind of makes it nice. Double click on that. Now here, it opens it up for you. That's super easy. So you just go here, right click, go to select data, and now you can just add your XY data. Now you're looking at your strain as your first data, right? So just select all of your strain. Go all the way down, all the way down. You can also do this manually in a formula. Right, so that's your S. Now your stress is going to be the same formula, but it's just I, right? It's just the stress here. So change this D into an I. Easy peasy. Boom, there you go. And that's it. Your stress strain data has been plotted. You can rename it as well to keep things consistent. Call it your this is brass. Done. Okay, right. Now I want to add my data for my aluminum, and I want to do it on the same plot. I want to put all my data on the same plot so that I can just get a look at all of it, see if I want to replot the backup data, see if my extensometer has slipped or not. So let's just do all of it. So go to aluminum, select all your strains. Oh, I made a mistake. I never did 0 error on my streak. So cancel this for now. Cancel that for now. Let's just, I forgot to do one part. So let's call this corrected strain, because you have to take the first 0 strain out at the 0 point, right? So mm per mm. And this guy is equal to this guy minus this guy, but you fix him. So you're taking the 0 error out, boom, like that, and then you go here. The old version of X, oh, it still works. You can just double click on that end and it goes down and calculates it for all of them very nicely. All right, now copy paste, so Control C, Control V. And you might have this extra data, so you can just get rid of that. Control C, Control V. Oh, sorry. Instead of doing Control V, you want to paste formulas. Good stuff, good stuff. Oh, see, and now you're missing data. So you want to go all the way down to your last point, go there and just double click. Boom, there you go. Does it for you. All right, now we're ready to plot our data. All right, so same thing as before. Insert, scatter, nice line. Select data, add, equal to, I want my strain data. Sorry, I want my corrected strain data. Take it all the way down, all the way down. Come on, go down, get down. Beautiful. And then your stress, which is this guy, you can select it manually if you want to go back up, because you have to go back up to see your plot anyways, right? So you might as well just get your stress along the way. Boom, there you go. All right, you can see the stress strain data. Hit OK. Let's call it brass. Okay, then you want to add more. Go to X equal to. Now go to aluminum. This will call back to that sheet which you're using, and now this is my corrected strain. So select all of it. All of it. Good. And here you're looking at your stress, so you can just copy paste this. And make sure your stress is I. So you change your E's to I's. I. Boom. All right, you get your aluminum data too, and it looks wonky. All right, let me. Oops, sorry, wrong one. Oh no. Oh, messed that up. Do it again. All right, brass. Oops, wrong one. Catch up, catch up. Brass, all right. So now go back, equal to, convert that into your stress. So I I call this guy brass. Okay, add equal to, go to aluminium. Get your corrected strain down. The same thing. Make that the stress. Your y-axis is the stress. Hit OK. Rename that guy to aluminium. Okay, and then you add your last one. So there, equal to 1020 steel. Corrected. All right, and then do the same thing for your stress. Okay, but as you can see, the stress wasn't complete. So, just make sure it is 1020 steel. And okay, oh, okay, what, did I do an equal to? Yeah, you did, all right. Getting a bit overzealous. Okay, okay. Now, for the points where you had some data missing, just go and complete that data. Boom, boom, wow. Like that, and like that, all right? So now here's your plots. Looking all right, except, you can tell. So now now you don't know which plot is which, right? So now you go to select your chart, go to chart tools, and what you can do is go to quick layout and make it so that it shows up the legend. I don't know what just happened. Go to the chart again, quick layout. There you go. All right. Now you got two axis titles. Call this one stress. Call this one strain. That's it. Your plots are complete. Now you get an idea that you can clearly see for the brass sample, your extensometer slipped, but it slipped towards the end. You should still be able to find the Young's modulus, the yield strength, the ultimate tensile strength, the resilience, right? You can find the resilience as well. But because it slipped, you can't find the ductility or the toughness accurately. So now you have to go to your backup measure of strain. So you select that, go to select data, go to brass, and change your x-axis to J because that's where your backup strain was. Okay, hit okay. And there you go. You have data where you have no slipping. Now, it'll give you a halfway decent measure of the stuff that happened in the end. But as you can see, the Young's modulus is going to be much different. But what are you going to do? Data is data. When stuff gets messed up, it gets messed up. But this is the best you got. So now you have this data. So do the same thing with your aluminum data, right? Plot it with a backup strain because it's very obvious over here that it slipped right here, right? And then it maybe slipped towards the end as well. I don't know what happened here, right? So do the same thing for your aluminum data. So go to aluminum, edit, and make that J as well, because J is where your backup strain is. Oops, Control G, Control Z, Control Z. All right, mess that one up. So hit equal to, go to aluminum, go to backup strain. And there's multiple ways of doing things. I don't have one way either, as you can see, pretty much all over the place. Okay, and see, your aluminum data is now fixed, right? So that's how you do it. To find the yield strength, look at the instructions in the YouTube video. Everything else, you just have to read off the points, right? You can just select the curve, read off the points where the stresses are, right? You can literally go to that point and curve, and then Excel will tell you what that point is. To estimate the resilience, you just have to find out what that the estimate what half times sigma y times the strain at sigma y is. That's how you find out the resilience. That's pretty much straightforward. Toughness is the trickiest part. It's basically the area under the curve. How do you find that out? The area under the whole curve. Well, what you've got to think of is you might have to, there's multiple ways to do it. There's many different ways to do it. The way that I would suggest doing it is that you can break this curve up into many small different rectangles, right? Based on how your strain is getting incremented, right? So this little bit of strain between points and a little bit of stress between points, those become your small rectangles. You find those out, multiply those by each other, and then just add them all up. And that will give you the area under the curve, all right? So that's the challenge here. Or you can estimate it as well, right? Just find what that area is, find what that square area is, then find what that triangle is, break it up into different pieces and estimate it that ways. If you want to do it that ways, that's fine. It's up to you to figure out how to find that data out, all right? Cool. So now you have all the tools and all the things that you need to plot your data and extract the information from them for the mechanical testing. So yes, please take note of the additional questions that have been added to your memos that you have to address for your handouts. Yeah, and also when you see open-ended questions like, what do these letters mean in these alloys or in these plastic, best advice I can give you is use Google. So just Google PLA, right? PLA opens up, it says it's polylactic acid. You get all this information on it. Wikipedia is your friend, all right? And then you can find out all of this information from there. It's amazing, all right? So that's how you use Google to find out those open-ended questions. We're not doing anything brand new in our lab and in our class per se. All of the stuff we're studying is well studied and well understood. So there's a lot of information out there, all right? So just use Google, your friend, and Wikipedia as well. All right. Okay. Hopefully that was helpful. You guys, let me know if you have any questions, and look out for an email from me. All right. Thanks. Bye.